So yeah, I'm here to talk about React Server Components with Next.js. Little detail there. The agenda is I'm gonna do a quick intro. I'm gonna talk about React. I'm gonna talk about Next.js. I'll explain what React Server Components are, and I'll go through this new principle and mental model. And I'll discuss the differences between server-side rendering and React Server Components. So hi, I'm Lucas Estevão. Thanks for having me today. I'm a senior technical manager here at Avnicol. I've been with this company for over a decade now, but I work in tech for over 16 years. And I've been specializing in front-end development as I progressed on my career. I also host a Brazilian Portuguese podcast about career in tech. So if you're curious about it, you can search Códigos de Carreira in any of the major streaming platforms like Spotify. Just out of curiosity, I'm a dad. I have 2 kids, Samuel and Daniel. I'm a kickboxing brown belt. I still practice martial arts. I love it. I'm happy to see that my kids are kind of following that path as well. And I came all the way from Belo Horizonte to California, where I lived for the last 5 years or so. So that's it about me. Let's start talking about React. According to Stack Overflow developer survey from the last year, 2023, React is the most desired front-end library and is the most used by professional developers as well. So you probably know React, and you probably know that React is this library for web and native interfaces. And I want to highlight a few aspects of this library. One, React encourages a modular approach to build UIs. That means that you should try to break down your UI into reusable components, very atomic components, if I may. React is also declarative. It follows this declarative programming style, this kind of paradigm where developers describe how the UI should look based on the current state of the web application. And this not only makes it easier to understand the code, but it also helps in a way to maintain it. Third aspect of this library is that React follows this unidirectional data flow pattern, which means that the data flow always flow in the same direction, always from parent to child components. This helps maintaining a predictable state management and also facilitates with debugging. So giving the developers a really nice user experience. And I know that there are many other aspects and specificities about React, but those concepts should be enough for us to get started. So for us to understand how React works, we can talk about 3 subjects here. One, we can talk about the virtual DOM, which is an abstraction of the DOM, or the real DOM. It's this DOM-like structure that allows React to keep a representation of the UI in memory. So whenever there is a state change, React is going to calculate the minimal number of operations that are needed to bring the real DOM in sync with this virtual DOM, with this abstraction of the real DOM. So check this image. The white circles are a representation of components. This is a component tree. So React leverages the virtual DOM to update the UI every time there's a state change. And we can think about it, thinking about a scenario like, imagine a user clicking a button, something happens on the screen, there's a state change. When the state of a React component changes, React needs to decide how to efficiently update that user interface. So we have this DOM tree. React keeps this DOM tree in memory in the virtual DOM. And when the state changes, there is this algorithm process that when React decides what is the most efficient way for me to update the real DOM with the changes that were caused by that state change. This process, this algorithmic process, It's what we call reconciliation. It's pretty much React comparing the real DOM with the virtual DOM and deciding, hey, what exactly do we need to update? We don't need to re-render every single component if not everything is updated. Again, this process is called reconciliation. Everything until now happens on the screen after everything is served to the user. So what about hydration? Stick with that concept there. We're not going to explain it just yet, but we'll get there. This is React. Now, what about Next.js? Let's take a look about, let's talk about Next.js first. So Next.js is this full stack framework that enables you to create modern web apps with the power of React components. It leverages React components. The interesting thing about Next.js is that as a framework, it provides this abstraction to multiple aspects of complexity that comes around when you're dealing with software development. And I want to name a few of them. For instance, rendering approaches. With Next.js, you can choose your rendering strategy. You may go with server-side rendering because you're concerned about SEO, and you might have a very dynamic website, or you go with static site generation because your site may not be so dynamic. So there are different approaches that you can choose from Next.js, and the complexity to implement the logic behind that rendering machine is abstract by Next.js. Another aspect is client-side routing and API routes as well. Next.js has this BFF layer where you can consume an API inside that unique place, connecting front and back end seamlessly. And it also deals with automatic code splitting, other kinds of optimization like image optimization, font optimization, a lot of little things that helps with the developer experience. Next.js is one of the most desired frameworks for UI out there as well. It is used by the biggest companies in the world. It's used by Apple, Adobe, it's used by Nike, Target, name it. You see Next.js a lot out there. We're talking about server-side rendering. I mentioned that before when I was talking about rendering strategies. So let's try to describe this a little more in detail. This is how server-side rendering looks like. And although I'm using Next.js as my framework of choice, the core concepts of this rendering strategy are the same for any other framework, like Next, for instance. So what happened is the server sends the HTML, the browser renders the page, and then executes React. Then hydrating that raw HTML. Here comes hydration. Hydration is the process of attaching all that client-side functionality into HTML elements that were rendered on the server side. Again, the server is going to send this raw, pure HTML. The browser is going to render the page. The user is going to, see something, see the experience there. React executes while it's downloading all the assets, the JavaScript, and this hydration process starts. After the HTML is rendered, React hydrates this static HTML, as I said, by attaching event listeners or setting up data bindings or initializing other client-side functionality, pretty much anything that it's necessary for interactivity. So when React hydrates, and this is an important detail, it assumes that the DOM structure will match. Whatever the server was serving to the client must match with the result of the hydration process. A couple of benefits worth mentioning of using this rendering strategy. One, it's faster initial page load. You're leveraging the power of the server to get that first initial load to your client. Two, better SEO, search engine optimization. I think I mentioned that before as well, since all the search engine crawlers can easily index server rendered content. There are other benefits, but those two are worth mentioning. Faster initial page load and better SEO. We're talking about React. We're talking about Next.js. which is a React framework. Now let's talk about React Server Components. React Server Components allow you to write UI that can be rendered and optionally cached on the server. That's how Vercel, the maintainer of Next.js, describes React Server Components. What is important here is that React Server Components are not regular components. React does not hydrate React Server Components like a regular component. Once the server sends the HTML, which is technically not HTML, it's a new format called RSC payload, React Server Components payload. React deserializes that content and it's done. We don't need the hydration process because React Server Components, one, do not send code to the client, and this contributes to smaller bundles. Great stuff. Less data consumption, resulting in faster load times as well. But it does not re-render and it does not require hydration because one of the limitations of React Server Components is that they cannot be interactive in a sense that they will not handle state changes. You cannot wrap a React Server component in a hook. A React Server component cannot rely on a hook. It must be kind of like, remember when you use it to write functional components, we didn't have to deal with logic inside of it, kind of like that. React Server Components do not re-render. It does not require the hydration process that we were describing before. And the good things about it is that, one, good for timing as well, performance, and improves the bundle size. Okay, wait, what? Kind of confusing. Doesn't it sound like we're talking about server-side rendering? Hold on, we're gonna get there as well. Let me show you a piece of code, a little example of a server component, which access data directly from the component. This is a React component, React, JavaScript. And this is accessing data directly. It's consuming an API. And I know it can spark some FUD, but hold on. Let me take a step back and clarify something. For us to be able to use React Server Components effectively, we need more than just React. React Server Components are part of React architecture, but we need more than that. We need a bundler. We need a routing system. How are we going to deal with the routes? And tell the client what do you expect to be served? And we need a server runtime to execute that. We need a framework, in other words, like Astra or like Next.js, which is the one that I'm using as an example today, and it's recommended by React on the website as well. Okay, but if that's an example of a React Server component, how does a client component looks like? And here is when new stuff comes up, new syntax and new directives. We have this new directive called use client. In this new React Server Components principle, in this new paradigm, all components are assumed to be server components by default. Everything is a server component until you opt in and tell your runtime, your library that, hey, this is not expected to be a server component. This is a client component. And I do that by using this directive called use client. And because it's a client component, as you can see, I can use hooks. I can use a state. I can handle state. I can have interactivity. I can have a click bind to that component. React Server Components is the first official way to run server exclusive code in React. And I know, although this isn't really a new thing, like in the broader React ecosystem, if you think about it, we've been able to run server exclusive content in Next.js since what, 2016 maybe? The big difference here is that we've never before had a way to run server exclusive code inside components only. That's the big deal. That's the difference. The most obvious benefit, as I've been talking about, and hopefully that's clear by now, it's performance, faster initial page load. And We also reduce the time needed to run hydration because React server components do not require hydration. They are not interactive in a way that they do not handle state. They don't deal with hooks. They do not require hydration. They are not expected to re-render as regular components do. So several components don't get included on JS bundles. It's the second benefit. We're talking about initial page load time. We're serving things faster to the user, but we also don't include those JS bundles, that logic, that JavaScript in the bottom. That reduces the amount of JavaScript that is needed to be downloaded, and it also reduces the number of components that need to be hydrated, as I was explaining. It all means that users can interact with the page sooner. In other words, if I had to summarize that, biggest benefit with React Server components, users can interact with the page sooner because the bundles are smaller, because hydration takes less time to be executed. But okay, Lucas, still kind of confusing. We're talking about server-side rendering. We're talking about React Server components. What exactly is the difference? And that's a fair question because on the surface, both are very similar. One, both happen on the server. Two, both intend to load content faster. Both are focused on performance and expedite that initial page load. But it's important to understand that these are two independent concepts. They are complementary to each other, but they are independent concepts. You can have server-side rendering without server components. You can have React server components without a server-side rendering approach. You can have both together. You can mix them together and choose server-side rendering as your rendering strategy approach and leverage server components in the same application, or you can have neither. They are complementary, but they are two independent concepts. So how can we understand the difference? Now, remember how server-side rendering looks like. Take a look at this again. The big difference here is that with React Server components, we don't fetch much AS anymore. And we don't need to hydrate those components. With server-side rendering, all of the React components from that tree will always hydrate on the client. Hydration is a must, even when there's no need for them to do so. Even if it's just a functional component that is never going to change, hydration will occur. One of the key things to understand is this. Server components never re-render. Keep that in mind. Server components never re-render. They run once on the server to generate the UI. The render value is sent to the client and locked in place. As far as React is concerned, this output is immutable. This will never change. I mean, it could change if you change a route, but otherwise, this will never change. Understand this, React Server Components is not a replacement for server-side rendering. They are two different things, complementary, but different things. React Server Components is built on top or can be built on top of server-side rendering, generating the initial HTML, which allows to omit certain components from the client JavaScript, reducing the bundle, and making sure that that logic is going to run only on the server. Remember the example that I've shown that server component was accessing data directly, consuming an API. I could have like a key on that code, and that wouldn't be a security issue because that code will never be sent to my client bundle. My client will never be able to access that logic. Hopefully I did a good job trying to explain this mental model. That was the goal. Understand this mental model behind React Server Components. React Server Components have its benefits and it has its limitations. Look at those two images. Without React Server Components, Next.js, our framework of choice, it needs an extra API to communicate with the server. So with React Server Components, it brings a benefit of simplicity. Compare the left with the right. The left without server components. There is more code, more operations being executed, so that works. The whole thing, it's put together and it works. So in a way, server components take a little of that complexity out. But in the other hand, all code written for server components must be serializable. And that's what makes it impossible to be interactive, which means that you cannot use lifecycle hooks like use effect, use layout, or use state. Because, as I said, when we explain it, we say that the server is providing with HTML, but it's actually not HTML. It's just a new format that React uses. But to simplify, let's say that it's HTML. However, you can still interact with server from the client through server actions. Wait. I was just telling you that server components are not interactive, and now you're telling me that I can't interact with the server. Yes. I don't cover this on this talk, but there is something called server actions, which is a way to create this channel, this direct channel from client to server. So you can do both. One, you can mutate the cache, and you can update the React tree in the same round trip request to the server. At once, in the same request, you can mutate the cache and you can update the React tree. But that's not really the subject. It's really more next steps. If you're really interested on React Server Components, take a look on server actions. It's much more than I could possibly cover in just a few minutes here. To finish, I want to finish with this. We do not need a server to use React Server Components. And that's mind-blowing. In fact, we do not need a server to use React Server Components. React Server Components is compatible with server-side rendering, as we were saying, and also other strategies like static site generation. So when our server components are rendered in the Node.js runtime, the JavaScript objects they return will be created, and that can happen either on demand or during the build time. So that's why you don't need a server. This means that it is possible to use React components without a server. We can generate a bunch of static HTML files and host them whatever you want. And in fact, that's what happens by default in Next.js app router, if you're familiar with that. Unless we really need things to happen on demand, all of this work happens ahead of time during build time. Yeah, React Server Components is much more than, as I said, I could possibly tackle in just a few minutes. But that's all I had for today. Thank you very much. And
All
yeah,
right.
that QR code, before I forget,
All right.
on the right, where you can see the little arrow, you can connect with me in different ways. And there is another one on the bottom left for feedback. I really appreciate it if you can provide with your feedback. It's very important to me. Thank you.
All right. Thank you, everyone. Thank you, Lucas, so much for sharing your knowledge with us. I would also, if no one has any questions, I would like to remind you to just answer the type form to evaluate so you can do better whatever you must do. So thank you, Lucas, so much for sharing with us your knowledge, all right? We'll see
Yeah, of
you
course.
on the next week.
Thanks for the
Uh,
comments, Thiago, William.
it was great. All right. Sorry, here we go.
Hey, yeah, the QR code for feedback is actually not working for me, I guess.
Oh,
The QR
okay.
code or the link on the chat?
QR
Yeah.
code.
Oh,
The feedback QR code is not working for me too. Yeah, but
Oh,
the link.
that's a bummer. Yeah, if you guys cannot use the QR code, and thanks for letting us know, try to access the link on the chat, the one Yander sent, and please let me know if you're able to access before we
Okay,
left.
yeah, that one works.
Is it working? Nice, cool. Thank you.
yeah, great. And thank you guys for the feedback on the feedback. We'll
Yeah.
improve that. All right. Thank you so much, everyone. Bye.
Yeah, thank you. Happy coding. Bye.
Thank you.